The next among the distribution plots is a violin plot. It's a graphical representation that combines the features of a box plot and a kernel density plot. It displays the distribution of continuous variable or numerical data across different categories or groups. The key features are the box plot, violin shape, width of the violin, and outliers. The common use cases for violin chart is to visualize the distribution of a continuous variable across different groups of categories, comparing the shapes and spreads of distribution between the groups, and used for highlighting the presence of multiple modes or non-normal distributions in the data. The best practices is to use the violin plots when we want to summarize the distribution of a continuous variable and compare it across different groups of categories. We must customize the appearance of the violin plot to highlight important features such as color-coded violins or outliers. Must include descriptive axis labels and titles to provide the context and clarify the meaning of the plot. We must choose the appropriate scale for the axis to ensure that the violin plot is easily interpreted. And we must interpret the violin point in conjuncture with other descriptive statistics such as measures of central tendency and variability to gain a comprehensive understanding of the data. So that's an example of a violin plot. Here, what is it trying to say is there is one box plot hidden inside, and it talks about median, first quartile, third quartile, and minimum, maximum. Everything is represented in the center black one. Along with that, the densities are also plotted. Here, two types of densities we have plotted. One for the one particular parameter in purple and another parameter with the green, so we can distinguish easily how they are distributed using the shape, widths, and all that. So that's a advantage of working with the violin plot. So another example of violin plot, you can see that all three, the bar graphs for all three are almost same. So the bar graph, the box plots are shown inside the with a dark brown shade. So if you look carefully, almost all the three box plots have similar properties, but still the data is distributed differently. So to explain more details about that, the first one, if you look at it, the spread of the data is less, the number of points is less, therefore the width is small. And at the middle one, the number of points are more, so width is large. The last one, more number of points are there which are more are in the middle of it, therefore the shape of that is different and width is more. So many information we can provide with one chart. So three informations we are providing about three different features and their distributions, their what you say, where their median is, where their so first quartile, third quartile, minimum, maximum of each one, and the distribution of each one is shown in different colors. And in this case, both left right side of the plot we are using same color, which means that it's just a symmetric to make a violin with shape of violin symmetrically. We are using its mirror image as shown in the previous case. The left part, right part, they are not matching, which means that the left part is used for one feature, right part is used for another feature. So that way we can make sure that more and more information can be put on one plot and make the things more easy to understand. So that's about while employed and some details about the distribution plots. And next session we start looking at various geoplots and their use cases, their applications. So till then, thank you.